All right, we're back again with the notes for 3.2 here, patterns of chemical reactivity. These are basically the different types of reactions. Now, we went through these in Chem 1, so you should be familiar with most of them. There's some new things to them. There's a few new names that we might call a certain type of reaction that in the Chem 2 book they use. I'll kind of walk through these, highlighting the information that is new or sort of important as we go. Okay, so the first one is a combination or synthesis reaction. Two or more reactants combine to form a single product. Now, this part is something that we didn't really talk about in Chem 1. Okay, so in a reaction between a metal and a nonmetal, the product is an ionic solid. So we can actually use this to predict the product of a combination reaction. So now in your notes, this is already completed out, but I'm going to show you, if you didn't have it completed, how you would end up with the product here. So imagine you were shown 2 magnesium solid plus oxygen gas. That's your reactants. Okay, how do we know what the products are? Well, they're both just single elements. So the only thing that can happen is they can combine. You can't like tear them apart or flip anything. It's just the same thing. So the only thing that can happen is they combine, the synthesis. Now, when you go to put them together, remember you're going to use your oxidation states or the charges, and you're going to do the crossing because they're ionic. So Mg is a 2 plus, oxygen is a 2 minus. Now remember, subscripts don't go along with it unless it's a polyatomic. Okay, these plus 2 minus 2, that reduces to plus 1 minus 1. Cross down, but it's the same, so you end up with MgO. That's where we get this. Okay, now, how do we know it's a solid? Well, from this. We have a metal and a nonmetal combining. The product is an ionic solid. And you just have to memorize that. Right? Okay. Second type, decomposition reaction. This is where one thing breaks apart to form 2 or more products. Decomposes, breaks apart. Now, on your hard copy of your notes, this equation is wrong. On the copy that I put on Google Classroom, it is correct. I corrected it. I didn't realize it until afterwards that it's written on the hard copies as NaN3, and it shouldn't be. It should be Na3N, and then I changed the balancing for it. So you might want to fix your hard copy if you're using a hard copy. Okay. All right. So this next part is also something new for Chem 2. Metal carbonates decompose to form metal oxides and carbon dioxide when heated. Okay. So what's a metal carbonate? A metal carbonate is exactly what it sounds like. It's literally a metal element combined with a carbonate. So as you can see here, metal element combined with a carbonate. Okay. We have, it is decomposing when heated to form metal oxide and carbon dioxide when heated. So the carbon dioxide is just CO2, we know that. Where do we get the metal oxide? Well, all metal oxide is the metal from the beginning, so it would be Ca. Ca is a 2 plus, and oxygen, which is 2 minus. You reduce, cross down, and you get CaO. So up here, this is actually a metal oxide as well. But this was not a decomposition reaction, so it's not the same. Okay, metal oxide. That's how you make it. All right. This you have to just memorize. Metal carbonates decompose to form metal oxide and carbon dioxide. It's a special type of decomposition reaction. Moving on. Combustion. So we did combustion in Chem 1. It is the burning of a hydrocarbon, a compound containing hydrogen and carbon. It typically uses oxygen gas as a reactant, and it produces carbon dioxide and water. Okay, the hydrocarbon, the compound containing hydrogen and carbon, is right here in our example. Now, it can also contain oxygen, but it has to contain hydrogen and carbon in order to be a hydrocarbon. Okay, that is the one thing that changes. Okay, it's always a hydrocarbon, but what the hydrocarbon is can change. The rest of this equation, the oxygen gas, the carbon dioxide, and water products always remain the same. Okay, now the coefficients in front change based on what our hydrocarbon is, but those elements or compounds always remain the same. Okay, again, you just have to memorize this. All right, last two, ones we did in Chem 1 as well, single replacement and double replacement. So the single replacement, this is the one that I use the example of a couple, like a guy and a girl dancing, and then either a guy or a girl, breaking in and taking the place. Okay, so an element in a compound is replaced by another element. There are two types of single replacement. There's cationic, and there's anionic. Cationic is where the positively charged elements switch. Anionic is where the negatively charged elements switch. How do you know which type it is if you're only given reactants? Okay, that's when you look at the single element. If the single element is a positive charge or positive oxidation state, then it's a cationic single replacement. If the single element, like in this one, the chlorine, is negative, then you have an anionic single replacement. Okay. All right. And last but not least, double replacement. Or in the Chem 2 book, it's sometimes called metathesis reaction. Okay. An element in one compound switches places with a similarly charged element from another compound. Okay. The key to these is remembering you have cations and anions. Cation comes first. So we got cation. We've got an anion here, that's the polyatomic. Okay, we've got cation, and we've got an anion. Okay, the cation from the first one goes with the anion from the second one. And the cation from the second one goes with the anion from the first. And this is always cation first, then anion when you do it. So, for example, they have the Ca, so the Ca is a 2+. Okay, the PO4. Now, notice you don't you don't bring the subscripts that are here over here unless it's part of a polyatomic like PO4. That's all one thing. But everything else comes from charges. So PO4 is a 3 negative. Okay, you can't reduce, so you just cross down, which gives you Ca3PO4. Okay, then the same thing here. You have the cation from your first thing, the K, the +1. You have the anion from the second one, the S, which is a 2 negative. You can't reduce, you just cross down, and you end up with K2S. Okay. All right. And that wraps up the patterns of chemical reactions. If you guys have questions, please make sure you message me in Google Classroom, or you send me a text or mind text or something like that. And, because we're not going to spend a ton of time in class on these since we had the video lecture. All right. I'll see you all soon.